Alright, so here's going to be 2012 free response number 6. Alright, this is non-calculator, guys. For 0 is less than or equal to t, which is less than or equal to 12, a particle moves along the x-axis. The velocity of the particle at time t is given by our equation here, cosine of pi over 6t. The particle is at position x equals -2 at time t equals 0. Okay, so that's really the three pieces of information I'm really pulling from this in our problem. Part A, I think, is probably the hardest part. Okay, especially being non-calculator here. For our interval 0 to 12, when is the particle moving left? Alright, so the first thing I'm thinking for part A is I want to figure out when my particle is moving left, which means v of t is going to be less than 0 to be moving to the left. Alright, so that means I need to also figure out when v of t is going to be equaling 0. So I'm going to set my velocity equal to 0. 0 equals cosine of pi over 6t. Okay, and now I need to solve for t without a calculator. Now understand, on your exam this year, you're going to get to use a calculator. I would type that into your calculator, and then right then and there you can see kind of what your graph is going to be looking like. Okay, this is really going to be a cosine graph. Pi over 6 is going to be a horizontal stretch by 6 over pi. So you can think about it that way. If I solve this algebraically, I'm going to take cosine inverse of both sides. Cosine inverse of 0 is going to equal pi over 6t. Okay, now this is really asking, when is our x value going to be 0? Okay, because we need to figure that part out. So it's going to happen a couple different places. Okay, so our x value is going to be 0 really when we're going to be on the line, well, on our y-axis here, which is going to be at pi over 2. It's also at 3 pi over 2, 5 pi over 2. If I were to go in the other direction, it would be negative pi over 2. Okay, so all of these are going to be equal to pi over 6t. Alright, so now when I go ahead and solve each of these, I'm just going to multiply both sides by 6 over pi. Okay, so I multiply both sides by 6 over pi. What happens here is t is going to equal pi over 2 times 6 over pi. My pi's cancel. This is going to equal 3. On my next one, t is going to equal 3 pi over 2 times 6 over pi. Okay, my pi's cancel. 6 divided by 2 is going to be 3. 3 times 3 is 9. Alright, we'll do it another time down here. We're going to get t is going to equal now 5 pi over 2 times 6 over pi. What happens? My pi's cancel. 6 divided by 2 is going to be 3. 3 times 5 is 15. Now understand that is outside of my boundary from 0 to 12. Okay, so we don't really care about that information, but I have gone far enough. If I were to check this one out, okay, this would be t is really going to equal negative pi over 2 times 6 over pi. Okay, my 6 over 2 is going to turn into 3. Pi's cancel. This is going to be negative 3, which once again is not on our boundaries from 0 to 12. So I'm going to be at 0. My velocity is 0 at time t equals 3 and t equals 9. So now we can just do a little sign analysis. Okay, what I care about is 3. I care about 9. Okay, my boundaries are really going to be 0 and 12. If you guys think about it, this is really representing, well, from 0 to pi over 2, isn't cosine a positive value?
Wow.
Okay, and then from pi over 2 to 3 pi over 2, which corresponds from 3 to 9, isn't x going to be a negative value over here for our cosine? Okay, and then 9 is really representing our 3 pi over 2, and we're just going to keep continuing. Now my x value turned back to positive. Okay, it would turn back to negative once we got to 15 again. Okay, but that's outside our boundaries, so don't really care about it. So we did all this work. We really want to know, when is our velocity going to be less than 0? Okay, so I would say particle moving left on the interval. Okay, we're going to say t equals 3 to 9. We do not want to include 3 and 9, remember, because at 3 and at 9 our velocity is actually 0, which means it's kind of standing still. It's not moving left, that's for sure. Because v of t is less than 0 on this interval, or at t equals 3 to 9. Okay, and that's all you got to do for part A. But like I said, I thought that was kind of the hardest part here in this whole problem, just because you're not supposed to use a calculator. And that's some hard stuff to figure out. Part B, write but do not evaluate an integral expression that gives the total distance traveled by the particle from 0 to 6. All right, so if you want the total distance traveled, you really just want to integrate velocity. So for part B, I'll hop up here. Okay, to understand the difference between if we integrate from 0 to 6 of velocity and when we need an absolute value. Okay? If you just integrate velocity, we're going to treat our negative area really as a negative distance. Okay? We don't want that negative distance to be taken away if we're asking for total distance. Okay, so we're going to have the absolute value bars here. Okay, because my velocity is negative from 3 to 9. If my velocity was always positive, then the absolute value and not having the absolute value would really give you the same answer, and both would be correct. Okay, but here, because our velocity is negative for part of that time, we would have to have the absolute value. Okay, so it's going to be very, very important. I think that's all you need to do for part B, so that one should be a piece of cake. Part C. Find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at time t equals 4? Explain your reasoning. So we first need to find acceleration. Well, a of t, understand, is just going to be the derivative of velocity. Okay, so make sure you say that. So we're going to take the derivative of our velocity, which we're going to have to do the chain rule. Yeah, so the derivative of cosine is going to be negative sine. Okay, remember your inside will stay the same. We got pi over 6t times the derivative of your inside now, which is just going to be pi over 6. Okay, you don't need to rewrite it, but I'm going to rewrite it. My acceleration is going to be negative pi over 6 sine of pi over 6t. Okay, now that was only the first part of part C. We also need to figure out, is the particle speed increasing, decreasing, or neither at t equals 4. Okay, so that's where we really want to do kind of sign analysis at 4 for velocity and acceleration. So as long as I have acceleration right here, I'm going to find a of 4, okay, which is going to be negative pi over 6 sine. Now when I plug 4 in, 4 over 6 really reduces to 2 over 3. So it's going to be sine of 2 pi over 3. Okay, so I got to think about, well, 2 pi over 3, I like always to draw the circle. Okay, 2 pi over 3 is going to be in this location. Sine is referring to my y value. The y value at 2 pi over 3 is going to be the square root of 3 over 2. So this is going to equal negative pi over 6 times the square root of 3 over 2. Okay? Now understand, we don't really care what this exact number is. We care about what the sign is. You got a negative times a positive, which means a of 4 is really going to be less than 0. All right? Now we want to figure out what v of 4 is. Well, v of 4, okay, is going to equal, we go back to our velocity equation. We're going to plug in 4, so this can be cosine. Okay, when I plug in the 4 here, I've got 4 divided by 6 is going to turn to 2 over 3 again, so this is really going to be cosine of 2 pi over 3. Okay, so 2 pi over 3 is still here. Cosine is referring to my x value. My x value at that location is going to be negative 1/2, which means that v of 4 is going to be less than 0. So this is really what we're caring about here. Okay, a of 4 is less than 0. V of 4 is also going to be less than 0, which means our particle speed is increasing at 4. So we just need to say that. Particles speed is increasing at t equals 4 because v of 4 and v prime of 4, or you could say a of 4, have same sign. Okay, now I don't have to say at t equals 4 again because I specifically said v of 4 and v prime of 4. Okay, if you just said v of t and v prime of t, then you're going to have to say have the same sign at t equals 4, but this is basically saying at t equals 4 for me. Then we got part D. Find the position of the particle at t equals 4. I'm just going to
get that. Oh yeah, that'd be good.
Yeah, we don't need this garbage.
Erase that scratch word.
Alright, so we need to find the position at t equals 4. I got rid of all that. So, understand I want, well, position is really going to be the integral of velocity. Okay? So, if I want the position at 4, I really want to know x of 4. I know my initial position was negative 2 at time t equals 0. Okay, don't forget about that. Like, that was the last couple words in your instructions. And then we never used it, never referred to it again, all the way until part D. So don't forget that that was up there. Okay, that's actually why I wrote that down. Is going to equal the integral now of velocity from 0 to 4. It's just the fundamental theorem of calculus. Okay? If you're to use a twist on the fundamental theorem of calculus, it's the same exact thing. X of 4 is going to equal the integral from 0 to 4 of v of t dt. Okay, but all we did was add over our initial position, x of 0. Okay? So,
hold on, I'm going to jump in. And if you think about this in words, you guys, when I taught you this twist, this was the kind of problem I used it on. Like, your final position, right? The final position you want at time 4 equals your initial position, where you start, plus the area you accumulate from your initial time to your ending time under the velocity curve. Like doesn't that make sense, conceptually? Oh, if I accumulate the stuff from 0 to 4 and I add where I start, shouldn't that give me where I finally end up at whatever time?
yeah, remember this is just displacement, right? Versus up here we were talking about total distance traveled. This is going to give you displacement. Okay, so you actually, well, if you had a calculator, you could just type this into your calculator, math 9 it, but we do not. So, we're going to actually have to integrate from 0 to 4 of cosine of pi over 6 t dt plus our initial position, which is really just going to end up being minus 2. Okay, now this is a little bit more difficult integration. Okay, we're going to have to do a little bit of u sub. So, we'll pick a different color. U is going to equal pi over 6t, which means du dt equals pi over 6. Okay, I always like solving for dt, so I'm going to multiply by dt on both sides. Okay, to get rid of the pi over 6, I'm going to multiply by 6 over pi. So 6 over pi du is going to equal dt. So I can do my u sub. When I do my u sub, now this is going to equal the integral. Okay, my integral is not going to be from 0 to 4 anymore, so just hold up there. Cosine pi over 6t I said was u. du, okay, because I'm going to replace dt with 6 over pi du. 6 over pi is just a constant, so I'm going to bring that all the way out front all at the same time. Now my boundaries here are going to be, I need to find u of 0, because that was going to be my lower boundary. So u of 0 is going to be pi over 6 times 0, which is 0. U of 4 is going to equal pi over 6 times 4, which we've done this several times in this problem, is going to give you 2 pi over 3. So we're going to go from 0 to 2 pi over 3. That's going to give me x of 4. Okay, and we did all that work. Don't forget about this minus 2 now. Alright, so when we integrate cosine integrated is just going to be sine. So we're going to get sine of u. Oops. We're going to evaluate that from 0 to 2 pi over 3. We still have the 6 over pi out front. It's going to give me x of 4, as long as I remember to do my minus 2.
Woo!
I forgot this last part was so long. Alright, so what this is then going to equal is I have my 6 over pi. Okay, I'm going to plug in 2 pi over 3, so we're going to get sine of 2 pi over 3 minus sine of 0, all minus 2. Okay, so we already figured out sine of 2 pi over 3 was going to be square root of 3 over 2. So we've got 6 over pi times square root of 3 over 2. Okay, sine of 0 is actually going to be 0. If you think about that, my y value at 0 is going to be 0. And then all minus 2.
And stop. Holy cow.
Yep, don't reduce that anymore. If you did, you get 3 square roots of 3 over pi, all minus 2, which you don't need to do. Okay? That was it. So let's talk about our points. So we've got 1 point back in part A if you considered our velocity equaling 0. Okay, I know we were supposed to find when our velocity was negative. I even wrote specifically when our velocity was negative, but if you remember my next step, I set our velocity equation equal to 0. Okay, so even though I never specifically said v of t equals 0, this is still saying 0 equals our velocity. You would get your points. Okay, you would then get 1 point for your interval. Remember, our interval was from part of moving left from 3 to 9. All right, so you get 1 point for that interval. And 1 point for saying velocity equals 0. And that's it. On part B, all right, obviously that was only going to be worth 1 point. We hardly talked about that one. Okay, but remember, you need the absolute value there for total distance traveled, versus if you don't have your absolute value, that's going to give you your total displacement.
And just to remind you guys about this, like, this is kind of the shortcut way that at this time of year you want to take. When we were doing total distance, and maybe if this were a little bit different of a problem, like a calculator problem, you could like partition it and say it's the absolute value of a part that's in between 3 and 9. That would be, no, that's where velocity is negative. Yeah, right? To like flip it up. But this is now what we're really looking for on AP. Like if they ask you about total distance, they do want that.
I think what Ryan's trying to say is here your other option would be is if you broke it up into 2 parts, you could integrate velocity. Okay, we know its velocity is positive from 0 to 3, so we could just do from 0 to 3. Plus then the absolute value
of the whole accumulation.
From 3 to 6 of velocity.
Because this part would be below the t-axis for velocity. And so when we accumulate, that would be a negative. We want it to be a positive, but it's way quicker to do this. But that's kind of what we had you do in the unit before you knew that. But now you graduated. You know that now.
Yeah, so guys, you're still gonna, honestly, if you were to actually have to figure this out by hand without a calculator, you're gonna have to split it up. Okay, but you guys are gonna get a calculator on your exam. Here they didn't want you to actually figure it out, so you could just type that into your calculator if you did need to figure it out with a calculator. But that's really it. Part C, you get 1 point for finding your acceleration. Okay, so you should have either one of these would be fine. And then you're going to get 2 points for your conclusion with a reasoning. Okay, now I would assume that if you figured out A of 4 and B of 4, that was probably going to be one of those 2 points, with your answer being your justification here, that they have the same sign.
Or if you accidentally said cosine of 2 pi over 3 was a positive answer, but your conclusion was right based on your wrong sign for velocity at time 4, you would probably get 1 out of 2. Like if your conclusion matched a wrong arithmetic mistake, they would give you 1 out of 2.
All right, then part D, you're going to get 1 point for your integral. So having 6 over pi times sine of pi over 6t. Something along these lines here, you're going to get 1 point. You're going to get 1 point for using your initial condition. I used it in the fundamental theorem of calculus. Okay, so I would get that point. And then you get 1 point for your answer over here. Okay. Want to add anything? That is all.